So now let's go to the probably the most interesting part in our discussion, how we can combine Ansible and Spack in order to make the installation process simple. Installation of the software on the cluster simple. How can we overcome all the common problems like offline sites, some complications with dependencies and so on. So in order to discuss it, let's start with Ansible. What is it? What is it, Ansible? Ansible is, again, some tool similarly to Spack. It is core of this tool is written in Python and available like a Python as a Python library. And it provides also a command line interface. Well, basically, same story with this, like Spack, which is very handy because we do not need to, provide additional software, additional tricks to make them both work together. Next, as an input, if you want to use Spack, usually you should provide two inputs. The first one is host inventories. That's basically a set or a single file or a set of YAML files or config files, which tell what hardware, what platforms, let's say, are available, what hosts are available, and tells which variables to use for this host. Let's say later on it will be clear what I mean by this. And the next part is tasks definition part. It's the stuff which define, it is basically set of YAML scripts, or even sometimes you can at least write some external modules in Python, but usually it's a set of YAML scripts which are organized as roles, tasks, or playbooks, and can be executed in order to do something with external hosts. Well, and actually, when you want to deploy some software on or configure it on an external host, which in our case are usually testbeds and clusters, you can do it with Ansible. Ansible will just connect to these hosts via some connector, usually SSH, by default SSH, and will do the stuff for you. The most pleasant part of the Ansible is that all that bits, this corp Ansible library and so on, inventories, task specification, they can be defined on the local workstation. And for the remote workstation, you almost need no dependencies. So Ansible talk to clusters and testbeds without any dependencies, without requiring any dependencies. So you don't need to install something. If you want to use Ansible, you don't need to install something on remote machines. So, and now when we want to combine Ansible and Spack, we'll have the following list of the dependencies, to be honest, with this approach. For local machines, we will need Python with some extra Python modules in order to install both tools. Then we will need SSH. We will need routines for unpacking packages. We will need Git and curl. Yeah. And on the remote hosts, we will need just Python with some basic requirements for Python in order to be able to run Spack on the remote host. Then we will need some shell. Well, it can be bash. Well, here is a small mistake. We will need also SSH client, SSH. Yeah. Then we will need some compiler, so Spack. Some compilers, so Spack could at least compile something some basic packages in order to use them later on. And then we will need make, again, unpacking tools and patch command. And basically, if you will take a look on this table, all these dependencies are very simple and usually are satisfied on all machines, on all clusters. So they are not so complicated. So let's go to the inputs for Ansible. The first input is inventory files. In inventory files, you define again the structure. You define hosts and how are they grouped together. And for example, in the folder I created, we have one YAML file which defines a grouping of hosts, and we have groups var folder, vars folder, which defines host variables for hosts for some specific groups of hosts. Yeah, and here is the content of this YAML file. We in this YAML file we define our clusters, which we want to use. We want to use Hawk, we want to use a Vulkan for HLRS group, and we want to make them both available to use workspace. For example, we define for them both some variable use workspace to true. Then we define the group PSNC, where we define host ego, and yeah, we do not define it to true. So basically, and then we group both these subgroups, HLRS and PSNC, into a single bigger group, Hidalgo, and define for this group variables Spack prefix, where do we want to install, where do we want to deploy Spack, and by default we tell for each Hidalgo host to set use workspace to false. So, and before you will proceed with usage of inventory, it's always instructive to check whether inventory generates the settings which you actually used to wants to use, and you can do it with the command Ansible Inventory. And this command allows you to graphically depict the hosts which are defined within inventory, how they are grouped, and what variables will be specified for each concrete host. Yeah, and here you see the output for the previous inventory shown on the previous slides. So now you can basically check availability of all hosts with Ansible with the Ansible command ping. And yeah, it's also instructive to do it before you try to install something somewhere on some group of the hosts or some specific hosts. And now let's go to the second component, second part of inputs, which we need. It's playbooks. So playbooks are simply some lists of tasks which we want to execute on the hosts, on the remote hosts, as well as definition of some default variables for these hosts and yeah, some default groups which to which these tasks can be applied. And for example, here I tell that we want to define this playbook for the hosts in the group Hidalgo. We want to set several variables for all, which are common for all the hosts, which will be common for all the hosts, and which are required to use this playbook. And this concrete playbook shows how to download tarball of the Spack and how to distribute it for all the hosts in the inventories. So So in this concrete example, we download Spack on the local host. We delegate the task of downloading Spack tarball on the local host and run it once, because we want to reuse this downloaded tarball for all hosts. And yeah, in the second task in this playbook, I simply unpack this downloaded tarball and unpack it to the folder Spack prefix of all hosts. So, and if you want to run this playbook, you can do it with Ansible playbook command. And this, and you should, as an input of this command, you should specify inventory file and also a playbook file. There is also an optional input -L, which allows you to shrink the list of hosts to some particular hosts or groups of hosts. So if you want to use to deploy Spack not for all hosts in the group Hidalgo, but just for the hosts Hawk and Eagle, you can do it easily with the option -L. So now, let's go to the next point. If you want to, after copying and deploying Spack on the machines, we should configure this configure Spack instance, and basically, which means we need to create YAML files for packages, for compilers, and so on. And actually, you can easily do it with Ansible, because Ansible has a command built-in command copy, which allows to define you some specific text which you want to put to a remote file, and it will create a remote file in a specified folder with this concrete text. Next part, well, for example, if we will use this particular task, then on the Hawk we will have the file repos YAML with the following content. So it seems that we know how to put Spack somewhere, how to configure it. So it looks like we are done, but not really. There is one more thing. If we want to use it on offline clusters, we need to take care of making offline mirrors. And that's the next thing which we have to do. In order to create offline mirrors, we can use two workflows. The first one, we can download Spack local. The first one is a simple one, which is cluster agnostic. We can basically download Spack locally, then create some generic mirror with some packages which are useful for the list of specs and environments interesting for us. And then to distribute this mirror along with Spack to the remote hosts and configure Spack there. And finally, create environments which we want to use later on. So now, how to implement this stuff? Well, in order to implement it, we have to use Ansible command shell, which allows to run some Spack command in this shell. And the concrete command which we must be interested in, mirror, the command for creating mirror. Well, this command can take as an input the number of versions of particular packages which we want to download. It can ask whether we want to download all the dependencies of this package or not. And it also can ask us for the list of packages which we want to download, and for the folder where we want to store the mirror. And yeah, if we will use this command in the Ansible as it is, we will face the same issue which I've talked before. If we will deploy another version of Spark on the system which already has Spark and user has used Spark of that system before, then it can produce interference with the files defined in the home folder scope of the Spark. So basically, what do I mean by this? Here you see, well, in the home folder of Spark, the user can define some external packages. And for example, and these external packages won't be downloaded by the mirror command. And for example, in this particular image, you see. In this particular slide, you see two images. The first one, which shows what the dependency tree of packages will be created by Spark when we have CMake defined as an external packages in the home folder of the user. And here, if we do not have defined any any external packages for the user, actually this, sorry. Actually, these images were produced by another useful command of the Spark, which is called Spark Graph. So now, if we want, how can we fix this problem? Well, basically, the easiest fix is to use some user-defined scope and to put everything there. In this case, and to put empty packages there. One may think that this, well, you might think that this could work, but in fact, it won't work properly, because besides undefined externals, if this particular content of the packages file will also remove all the preferences for the packages, and also will remove all the other stuff which was defined on the upper level scopes. In order to do it in a safer way, you can simply copy packages YAML file from etc Spark defaults from the default scope to etc Spark, to the scope which you want to use. So now, when you have this done, you can create a mirror also for the environments. And for creating mirror of the environments, you have to simply switch to the concrete environment, concretize it, and then move mirror create, but without the parameter which defines the list of specs for which you want to create the environment. And if you have several environments, you can loop over them in Ansible. So that was the first workflow for creating mirror, but it is an error-prone workflow. So in some, why is it error-prone? Is that because it's cluster agnostic. So it downloads all the packages, but on some particular clusters, the Spark can be configured in a way that it has a little bit different preferences for the packages. And in order to make it, and it will concretize all the packages in a different manner. And in order to make it work, you can use the following workflow. for defining your playbook. You can download Spack at first at the local workstation, then you unpack and configure it on the remote workstation, then you concretize your specs and environments on that remote workstation, and this will take care of all the issues related to the preferences in the concretized specs and concretized environments. And then you can copy this concretized stuff to the local workstation to create the mirror. Then you can create the mirror with mirror create and copy this mirror, which is already aware about it, about the remote workstation, to the remote workstation and register it finally. That's the whole workflow. But the only difference between this workflow and the previous one is that in this workflow, we will need much more downloads. We'll need to create mirror, separate mirror for each remote workstation. Pardon. So now, what we, with all that said and done, what we have for the answer on the topic which for the answer on the question which I posed on the beginning of the talk, on the beginning of this training. So the question was how to reproduce general software environments on the resources of several HPC centered ones, and to make it as simple as possible, to make it close to pip install in a way. So, and what do we have for Ansible for Spack for Ansible plus Spack solution? For Ansible plus Spack solution, we should define, we still should define logical environments, or we can take exact environments if somebody provides us exact environments and want to reproduce it somewhere. And then we should run the following command. We should run the playbook which installs Spack, and the idea behind this playbook is was demonstrated before for the inventory. And the next step is to launch Spack command on all the hosts, which can be done if everything is installed well, if Spack was installed well, which can be done with the following command, Ansible command. So now, and the next point, which is also worth to mention, which is also related, closely related to reproducible software environments and reproducible research in HPC, in performance studies at all. It's that Ansible and Spack also help you to report all the hardware and operating system configuration easily, and also all the software easily in the YAML format, for example, or JSON, whatever you prefer. And in order to report something in the YAML, in order to report platform in the YAML, so in order to report hardware and operating system in the YAML, you can use Ansible command setup, which collects facts about the remote platform, such as processor, operating system, and so on. Then in order to report software, on the other hand, you can simply slurp the environment log log file for the environment which you want to report, and then transform it to the YAML file with the following syntax in your Ansible playbook. So With respect to reporting software, you also have another option. You don't necessarily need to slurp the Spack log file, although it is a safest solution. You can also use commands Spack find and Spack spec, which which also can produce JSON and YAML output with quite a lot of detail of the installed software. For example, here, with respect to Lipo SRM, I will have a very big output which details on the feature of processor which was used for the installation on the platform, on the version of SRM, on all the dependencies and so on. So now, if you want, but all that stuff is can be done. What I've told how to do all that stuff from the local workstation, which means that all of that will be applied to the login nodes. If you want to apply it for the compute node, you can do it with the following option: connection local. And you should, as an inventory, you should just define a local host. So, of course, reporting the stuff with Spack has sometimes troubles. For example, when I tried to play with it on the cluster Eagle, deployed on the PSNC Poznan Supercomputing Center, Spack has found the following information, only the following information about the processor, that the processor is common KVM processor, which does not tell much. It doesn't tell what this processor is exactly. So, but when I checked CPU info, actually prod CPU info, the content of the prod CPU info was actually the same. So basically it tells that Spack uses prod CPU info to fill in this information. And it means that you can't do better if you don't have external sources of data, of information about the system. So now that's I've told you about some topics related to the Spack, but it's not everything which Spack can do. For example, one thing which can be interesting for the users and for the HPC providers of the HPC clusters is that you can also much speed up the installation of the software. Spack supports such features like binary caches, so which allows to share pre-builds. It supports parallel installations, parallel builds. It supports containerization, basically not containerization, let's say, but generating of the recipes for creating containers. And it supports module files, but I don't think that it is too much useful if you, since you can do the same stuff with module load, module find, Spack load, Spack find, sorry. And it also has complete integration, not complete, but quite nice integration with GitLab CI and C-Dash, which is another big topic and useful stuff. You can read more about Spack from the resources mentioned on this slide. So, and the last what I want to say is thanks to the Spack and Ansible development teams, as well as users Alexander and Camille, who helped me with understanding Ansible in some sense. And European Commission for the Hidalgo project, Matt Groening for the nice cartoons, Simpsons cartoons, and for you, for your attention. Thank you. So with this, I stop. Just wait a little. I stop recording. And we can go to the questions if there are some.